Greetings and welcome back to the lab. We're going to continue our series on Garden of Light, where we're talking about basically lighting projects in the garden and some of the more technical sort of stuff this time. Let's take a look at some of the things we can do. Last time we took apart one of these standard garden lights. And this time we're going to talk about the innards of these solar lights and what we can do to modify them. So if we put a battery in here, you can see that if I switch it on, we've got light. Now this switch is still active, and one of the first things I do when I'm modifying these lights is for this switch, if you look at it, the switch is on this side. So it's these three contacts on the circuit board, and really all the switch is doing is breaking the contact of one side of the battery so that effectively there's no power going into the booster circuit to power the LED. So all it's really doing, if you switch it off, is just disconnecting the battery. It's the same thing as removing the battery. Now, before I get too far into this, I want to say that, I could sit here and talk about hacking, and I could pull out the soldering iron, and I could do a whole bunch of stuff. It would make it a very long video. So I'm going to shortcut that by bringing in my test rig. Now, this is what I use to figure out various different possibilities. Now, this battery here is actually pretty worn out. It's not a rechargeable battery, but it doesn't really matter when you're testing what kind of battery you use. So I'm going to go ahead and put the other battery in there, and you can see I've got a light that has lit up here. Let me actually kill some lights here, make it a little darker so you can see the light is lit up. And so I'm going to have to go back and forth on that. So as you can see, I've already got a yellow LED sitting in here. This is not the standard white, so I've already swapped something out. But let's go ahead and see if we can't swap. This is one of those white LEDs that I've harvested when I've done modifications. I'm not just throwing the LEDs away. One of these days I may have so many of these I'll build a flashlight or something. But let's go ahead and see. Now with the LEDs, it does matter which direction you put them in. There's two pins, and it matters which one goes in which hole. But this breadboard is really useful for this kind of testing. So I'm going to pull this yellow. And I should mention, basically what my test rig is a couple of wires for the LED that are actually soldered to the original board where the LED, let me give you some more light here so it's a little bit more obvious, where the LED was originally. Sorry, it would be over here on the circuit board. It's a little hard to see, but effectively I have moved the wires from the circuit board over to the breadboard for the LED and also for the inductor. So I've got those available. I can try and swap out the LED or swap out the inductor and figure out what it is I want to do for a new design. And let me go ahead and plug in. Yep, I got it right the first time. I got lucky. So you should be able to see there that that is lit up. Let me kill the lights and show you again. So there's the white LED. So it's a pretty simple matter to swap them out. If you're modifying the light, you're going to take the existing, and to get the old LED out, if you want to swap it, if that's what you want to swap, there's a couple of solder joints here. You're going to heat up the solder, and you can usually just kind of pull on this LED. If you can get a fingernail under it, then you can kind of put some pressure, and I hold it like this while it's putting pressure on the legs of the LED. Once I heat it up, then it just kind of pops out. Then the fun part is trying to get the extra solder off of there, and for that I usually use my handy dandy solder sucker. It's something I bought and has paid for itself. The other option would be to use solder wick or an actual desoldering iron, which has basically a pump built into it, heats it up, and then you just push a button or something and it sucks it out. I don't have one of those. I have just a soldering iron and a solder sucker. I do have some wick somewhere, but it wasn't very good. So that's basically, that's how you get it out. Once you get it out, then you can put the new one in. You just got to make sure you get the polarity right. That sort of explains a simple swap of the LED. Let me try and pull out this white LED and show you, say, a green LED. Now these tend to be about the brightest you can get. And, oh, I got lucky again that I put it in the right direction. After a while, you can actually kind of look at the LED, and I don't know how well that might come out on video. Let me sort of stand up and see if it'll... Oh, that's right, I locked the focus. That's going to make it harder. Let me get some more light on it. That should help a little bit. So I don't know if it's going to come through, but it's the shape of the little metal parts inside that green lens there. Once you learn what you're working with, you can actually look at those and figure out which direction you're going to plug it in. But there you go. That's the green. We'll kill the light so you can see what the green looks like, how bright that is. Now, what I'm going to do, I'm actually going to leave the lights off, because the next thing that we can play with is we can actually take, I've got here, well, let me actually put light on the subject so I can point it out. I have here a series of inductors so that I can easily just swap. I take this one wire and I can move it to a different inductor, and when I pull it out, the light's going to go off, but when I put it back in, it should be a different intensity. And that one's not connected. And there's one over here. This is about as bright as I can possibly make it. This is the lowest value inductor that I have in my box of inductors. This is a ridiculous amount of power going into this green LED. Let me kill this light so you can see just how much brighter. I'm not sure if that's going to come through on camera, because the camera's going to try to readjust a little bit. But let me try switching down to a higher, lower intensity, higher inductor. So that's, I'm going to leave the light off, and I'm going to switch from this one to a high intensity, low value inductor. And hopefully you'll be able to see the difference. I'm not sure how obvious that's going to be. Let me try that with a different LED. I'm going to swap out the green for red, which are notoriously hard to get a good bright red LED without expending a ton of power and draining your battery quickly. So when I do these garden lights, red is the hardest to work with. So you can see that seems fairly low intensity, and that's actually on the highest intensity, lowest value inductor. If I now switch to the same one, okay, that did not work the way I expected. I think I need a different red LED. I think this just adjusted the voltage on me without realizing. All right. All right. It turns out that while I had a lot of this planned out, it didn't actually work the way I expected it to, and I think that's because the LEDs that I picked, including this green one, and I have a blue one here too, all came out of a set of Christmas lights. How appropriate, I'm doing this right around Christmas. Did not from the current crop of Christmas lights, from an old string of LED Christmas lights that enough of it had gone wrong that it was worth just harvesting all the LEDs out of the string. So that's one source for you if you want to try that. But maybe I'll just ask you to believe me that some of the red LEDs that are floating around out there are notoriously hard to light up. This one just seems to be working for me, and it's roughly the same intensity as, let's see if the blue is the same intensity and if I can get it plugged in the right way. And of course that would be the time. I'll flip it around, plug it in. So I don't know if that's going to end up looking on camera the same intensity, but there's a blue. So let's just say that some LEDs will be more intense than others. Greens and blues tend to be much brighter than the reds and oranges and yellows. Then you get into the animated LEDs, which is something we'll talk about in a minute. Let's try one more thing here. I'm going to pull this LED, and we're going to put in a blinking LED. And that is what I call an animated LED. It's got extra circuitry built in. Let's see if I get this in the right direction. Nope. Let's try flipping it around. There we go. It's lit up, but it's not blinking. And the key here is that the way these circuits work is you got to understand that it's turning the voltage on and off repeatedly very quickly to the point where you can't perceive it, but there's effectively a little computer inside this little LED package that has the circuit to make it blink. And if you think about it, if you turn off a computer and then you turn it back on, you have to wait for it to boot up before you can do anything with it. Well, with these LEDs, if you turn them off and then back on, they go back to an initial state, which is, it starts with the on position, and then it turns off, and then it turns on, then it turns off, the LED itself, not the circuit. Well, the problem is that the circuit is interrupting that process. So as soon as the power of the circuit comes back up, the LED goes back to its initial state. So it's always on when you're looking at it. And in order to get it to blink, you have to smooth out that voltage. And the simplest way to smooth out the voltage is to add a capacitor. And this is a tiny little capacitor. You might experiment with whatever capacitors you have lying around. And I've got a couple examples of capacitors here. You're probably going to want to fish through your parts and see what you've got. The actual value of the capacitor is less important in these particular circuits. I suppose if you put in a really high value capacitor, a really low value, you might have one problem or another, but in general, I just pick random capacitors. I also have, for these circuits, I found that I had these tiny little capacitors, and these work beautifully because they fit into the circuit. They don't take up a whole lot of room. But honestly, there's enough room in this casing to fit something like this one. So let's give this a shot. I'm going to move the LED back so I've got enough room. Now the LED is still lit. I'll show you that. And I'm going to put the capacitor in across the LED. So in other words, the same two connection points, the LED, I'm putting in the capacitor. It's kind of fighting me going in there. Now it did dim the light. Well, let's see. Are we blinking yet? We're not blinking yet. But it also dimmed it. So I'm going to move the wire here to a lower value. And hopefully you can see it gets brighter. Let me go to the big one that, wow, did I do that wrong? Now I got to question whether this is actually a blinking LED. So that's an opportunity to show you one more trick when it comes to playing with LEDs. I'm going to pull the LED out, and I'm going to get myself a button cell. We got one right here. And if you want to test an LED, these 3-volt button cells, if you get them in the right direction, oops, you just put one leg on one side and one on the other side, and I can confirm now that this is a blinking LED. So you can see the hassle that happens when you try to design these circuits with the animated LEDs. Let me give this another shot. I'm going to pause and I'm going to come back when I have a solution for what went wrong. It looks like I finally figured out what went wrong, and this was something I was going to cover later in the video, but now it seems appropriate. Sometimes the capacitor is not enough. sometimes you need one more component, which is a diode. Now, a diode is basically the same thing as a light emitting diode, it just doesn't actually emit light. It doesn't consume as much voltage. Generally, they're about a half or 0.6 volts across them. Bottom line, if you put a diode first, now I moved over the negative lead going to the LED, and let me put some light back on this and show you. So I moved the negative lead over. I had the positive and negative right next to each other because the LED is small enough it fits in two adjacent holes here. I moved it over so I could put a diode in here. That diode, the negative side of the diode is going to go at the negative lead, and the positive side is going to go to the more positive side of the circuit. So that then goes over to where I originally had the LED and the capacitor. So it's the diode and the capacitor in combination that allows the animation to work. And to prove that, hopefully nothing else goes wrong now, but to prove that, I'm going to attempt to put in an RGB LED. And is this my RGB? I think this is my RGB. It's a clear LED, so it's hard for me to tell exactly what I've got. But I'm going to go ahead and pull the blinking yellow and put in, if I can get in there. Okay, I'm going to push those components off to the side. There we go. There is my RGB LED. It does the slow first, and then it does the fast, and then it goes back to slow. So there's a program here. There's effectively, like I said, a little computer running in there. And by smoothing out the voltage, we've made it so that it doesn't reboot the computer every spike of the voltage. I know this is getting rather technical, but this is what you need if you want to get these working in these standard sort of solar garden lights. Now, just to sort of prove a point here, I'm going to pull, it's hard to see with this thing glaring in my own face, I'm going to pull the diode, which turns it off, but I'm going to go back to just the capacitor, and notice that it's no longer animated. This is the initial state of this particular LED. It starts with this particular color. And so what's happening is it is repeatedly rebooting, even though we still have the capacitor in circuit smoothing out the voltage. So that diode is sometimes very important. Sometimes you can get away with just the capacitor with certain animated LEDs. You just have to experiment to see. Now, let's see. Let's try one more thing. I'm going to actually change the intensity here. Hopefully you can see how much brighter that is, and it's actually more of a white now because it's combining all three colors. If your voltage is too low, well, actually that seems to make sense. It starts on white. I'm not sure what happened that I ended up with that sort of cyan color, but that said, there's one more thing I wanted to talk about in terms of the kind of LEDs that you can put in here. And for that, I'm going to go ahead and remove the capacitor. And actually, I'm going to remove the LED. I'm going to pull out the capacitor. Now we are back to, just for the sake of argument here, oh, I got it backwards. We're back to the standard circuit with the white LED. Now there's another thing you can do that I have discovered is you can combine LEDs. So I'm going to take a green, I'm going to put that in. I got to get it the right way around. I'm going to put that up close to the wires there. This is an old breadboard, sometimes it fights me. And then I'm going to grab a blue LED, and I'm also going to put that in. And now I've got both LEDs running at the same time. You can combine two different color LEDs to create a custom color. You could take that and one of these covers, and you could test to see what it's going to look like with the cover. This one's not so clear, so you're not going to really see the patterns that develop around it. This is an old one. Let me see if I can find a newer one. Should have had this. Oh, I know. I got a brand spanking new one right here. There you go. So hopefully you can see that that will spread some patterns around. The other thing you can do with these is you can get a piece of paper, cut it to size to fit right in here, and when you do that and you put it over the LEDs, it diffuses the light so you get the combination of colors. And that is something that I have employed on a few of my garden lights that I have now, where I couldn't find the aqua-ish color available easily or inexpensively. So I already had some blues and greens. I put them together and I get a nice aqua kind of cyan color. So that's, if I just leave the paper there, you can still see it too. So it's a question of what you want to do, depending on your own particular preferences. The other thing you can do is if I take the blue out now and I try and put the red in, we're going to have a little bit of a problem here. And of course I got to get it the right way around. There we go. Well, actually this one worked out. This did not demonstrate what I was trying to demonstrate. Let me try a different one. Yeah, that's the RGB. What happens if I go with the white? I honestly was trying to demonstrate something real. I'm not getting the white to light up. Probably because I have it the wrong way around. There, you can even combine a color with white and you get sort of a tinted white. But that's not what I was trying to demonstrate. So let me grab one of my other LEDs. And we want red. Pull them both out rather than going back to the well. Let's see if this red does what I'm trying to demonstrate. I just want to show you that I'm wiring these up in parallel, meaning that two positive legs are connected and the two negative legs are connected. And I got to get it the right way around to demonstrate. There we go. So I plugged in the red and the green went off. If you remember back to the previous episode, I mentioned that the voltage spikes go up until the device turns on. In this case, it's whichever device turns on first. And because a red LED is typically around 2 volts required to turn it on, and a green LED is around 3 volts, as the spike goes up, it hits 2 volts, the red LED turns on, and then the spike collapses. So it never gets up high enough to turn on the green. But we're not dead in the water. There's the green back. And I'm going to take this wire and move it over one. And I'm going to wire these up in series, which means that the negative leg of the red is going to connect to the negative power. The positive leg of the red is going to connect to the negative leg of the green. It's like putting 2 batteries into a flashlight. Typically, if you need 2 batteries to power a flashlight, it's because the 1.5 volts on the battery is not enough. You need the 3 volts, so you're putting 2 of them back to back in series to get 3 total volts. That's what I'm doing with these LEDs. And now I can have both red and green at the same time, although honestly the red is pretty dim. I can take the intensity, I can change that, but it doesn't really help all that much. So certain color combinations, depending on the type of LED that you have, This is a 2-volt LED, 2-volt red LED. I think what's happening is this is a 3-volt red LED. So if I move to this one, and of course I've got to plug it in the right direction. There we go. I've got both of them, but honestly, it's not very bright. So some color combinations just aren't going to work out. You can experiment with different LEDs. Not all of them are going to work. I could go back to, at the very beginning, we had this gold LED. Let's try that. See what that ends. Oh, sorry, that's a red. Oh, this is one of my bicolor LEDs. That's red. If I flip it around, I think this was a yellow. This is a special case of LED. If I could get it to actually plug into the right holes. There we go. So it's yellow in one direction, it's red in the other direction. These are special. They're called bicolor LEDs or dual color LEDs, depending on where you're looking on eBay. But I can have both of these colors at the same time. Yellow and green, I don't know how interesting that's going to be. It's not exactly going to make blue because it's just not. Let's put the paper around it and see. Does that look blue? Not really. That looks to me like a yellowish green. So that's what I get out of that. If I pull this out, go back to the blue, which we already did. But this is doing it in series. Now in series, notice it's not nearly as bright as it was before. Here is our sort of aqua-ish color. But if I change this so that they are in parallel, and I have to move my power over, now you can see it's considerably brighter and giving me that sort of aqua-ish color. Basically what this all means is that you're going to have to experiment, and for that the breadboard setup is beautiful because you can try different things without doing a lot of soldering and unsoldering. And honestly, these circuit boards in these things are cheaply made and the solder is cheap, and if you heat them up enough times then the tracks start coming off. It's just a disaster. These things you're buying for $1. Don't expect them to have heavy-duty circuit boards in them. So you can only do so many operations to modify these things, and that's why I highly recommend a setup like this, where you just literally have the wires coming over, so you can play around with different settings. Once you find the setting that you want, then you go ahead and you do this. And as far as these LEDs, the other thing I need to mention is you can actually wire these two LEDs together and have only 2 leads to plug into the circuit board, because you can't fit both leads through at the same time. So you're going to have to do something like, if I can find, I had one that I built. Let me turn the light back on. I had one that I built, let me move this out of the way even, where these are actually in series. So I've connected the 2 middle pins together and bent everything to shape so that it would fit like a regular LED into the circuit. So this is just something I tried. This particular one, though, if I plug it in, if I remember right, is not going to work because I goofed when I put this together. Oh, it does work. There was another one I'm thinking of. And so that is a combination of white and green. And that's using just the 2 leads. And if I put the piece of paper over it, you get kind of a green cast on your white. So if that's what you like, make a bunch of those. If you don't like it, make something different. Have fun with it. But that's basically how we do these modifications, or how I do these modifications of very simple, very inexpensive solar garden light. And with that, I'm going to wrap up this episode. Next episode, we're going to talk about battery testing. And with that, I'm going to wrap this up. So we'll see you in the next one.